Hello guys, so we are going to continue discussion with respect to statistics. In this video, we are going to discuss about log normal distribution. So this is specifically a new distribution that we are going to learn. In the previous video, we have already covered normal or Gaussian distribution. We saw in normal and Gaussian distribution, we usually get this kind of bell curve. And we obviously know the empirical rule, right? This empirical rule assumptions we also definitely know with respect to Gaussian or normal distribution. But what exactly log normal distribution is, what is the example of that, we'll be discussing in this specific video. And I will also be telling you like what all data set can probably fall in the log normal distribution, right? So let's first of all go with respect to definition. So in definition over here, you can probably see that in probability theory, a log normal distribution is a continuous probability distribution of a random variable whose logarithm is normally distributed. Thus, if the random variable x is log normally distributed, then y is equal to log of x has a normal distribution. Okay. Now, I know I've just read this, and that is what I usually do. First of all, I'll try to display the definition so that you can understand. Now, let me just go ahead and explain you this. Okay. So over here, it says that x, which is a random variable, will belong to a log normal distribution. Okay. So here, what I'll do, I'll write it as log normal distribution. Okay. Log normal distribution with some mean and standard deviation. Okay. Now let's consider x is a random variable that belongs to a log normal distribution. Okay. And whenever we say about log normal distribution, one thing you need to understand, in the left hand side, I have displayed a figure. Okay. In all this distribution, you can probably see over here, the mean is constant. Okay. The mean is constant like 0. But over here, you can also see with respect to other curves, the standard deviation is changing. Now, when standard deviation is changing with respect to the log normal distribution, you can see the right part of the curve. It is quite elongated, right? So we specifically say log normal distribution is a right skewed distribution, right? It is a right skewed distribution. And we know, we have learned about right skewed distribution. We also know what is the relationship between mean, median, mode in a log normal distribution, right? So over here, you can see with respect to every curve on the right hand side, the right side, it is completely skewed. Okay. So one example, let's say if I am probably trying to draw, right? So this is what a log normal distribution looks like, right? So right hand side will definitely be skewed. Similarly, you can have different figures, but in all the figures over here, you'll be seeing that right hand side will be skewed. So this over here, you can see somewhat right hand side, right part of this particular curve is skewed. Here also you can see right part of this curve is skewed. Here also you can probably see the right part of this particular curve is skewed. Now, let's consider x is a log normal distribution with some mean and standard deviation. Then if I probably try to do some transformation where I calculate a random variable y, and this y variable is calculated by using a formula log of x. Okay. So log of x, this log is specifically called as natural log. Natural log. And in mathematics, we usually denote it as log to the base e. Okay. So whenever we have log to the base e, that is basically called as natural log. So over here, what we are doing is that if I have a random variable which belongs to a log normal distribution, now if I try to create a random variable y by applying this particular formula, that is log of x. So in this random variable, how many values are there? In all the values, I'm probably applying natural log. Then this specific thing, this specific variable y, which is a random variable, this will belong to a normal distribution. This will specifically belong to a normal distribution. Okay. So that is what this specific sentence says. If the random variable x is log normally distributed, then y is equal to log of x, which is natural log of x, has a normal distribution. And that is what the entire log normal distribution talks about. Now, equivalently, if y is equal to natural log of x, then I can also define as x, which is a random variable. And suppose, let's say, if I probably try to calculate x with the help of exponential of y. Let's consider y is a normally distribution, right? Let's consider if I have a random variable y, which is log normal distributed, right? Sorry, which is normally distributed. Let's consider this y is normally distributed. Then if I apply exponential operation on top of y, right, on top of y, then I get x, and this x will be a log normally distributed. Okay, so this is what, this is just the inverse of this, right? Just the inverse of it. Before I had natural log of x. Now if I probably move this log to the left hand side, then it will become exponential of y, and finally I'll be getting x. So vice versa also you can get it, right? Let's say if x is a log normal distribution, if you apply on top of it natural log, then you get a normal distribution. And then if you have a y, if you probably have a y which is normally distributed, and if you apply exponential on top of y, then you will probably get a random random variable which will be log normal distributed. So these are the important conditions in log normal distribution. So about this, the second one, here you can see equivalently, if y has a normal distribution, then the exponential function of y comma x, which is nothing but exponential of y, has a log normal distribution. And that is what we have actually proven, right? So it is very simple. Let's say if I have a random variable which has this kind of distribution, right? Which has this kind of distribution. Then if I apply, let's say this is my x. If I apply ln of x, then I will probably get a Gaussian distribution. Okay, I will get a Gaussian distribution. So here I will probably get a Gaussian distribution, something like this. And vice versa basically means that if I probably have this normally distributed, if I apply a function exponential of y, this is basically my y, right? And then I will probably get this kind of log normal distribution. So this is normal distribution, okay, and this is log normal distribution. But the question rises again, how do we check whether a distribution is normal distribution or not? For this, we specifically apply QQ plot. Okay, so in QQ plot technique, we get a technique to check whether the distribution is a normal distribution or not. Okay, so this was the entire understanding about log normal distribution. Now let me just go ahead and talk about some of the examples. So first example over here, okay, which definitely follows a log normal distribution. Number one, the wealth distribution of the world. Okay, the wealth distribution of the world. So here I have the wealth distribution of the world. So usually in this scenario, what will happen is that, let's say if this is your distribution, okay, so in this particular scenario, you will be seeing that very less number of people will be having more wealth, right? So if this is wealth, okay, so in this scenario, you'll be seeing very less number of people will be having more wealth. Actually, in this world, right, where with the entire wealth distribution, maximum wealth distribution is basically with that 1% of the richest people in the world. So in this area, you'll find people like Elon Musk, Adani, right? You'll find other people like Bill Gates and all, right? If you probably consider this region, specifically this region is basically the salaried class people. So definitely whenever we talk about wealth distribution, it definitely follows this distribution. Now the second example, and like this we have a lot of examples itself, in discussion forum, right? In discussion forum, okay, you can probably see the length of the comments, okay. Now there will be many people who will be writing small comments. Like there'll be less number of people or more people who will be writing smaller comments. There'll be also many people who writes, or there will be very less number of people who writes longer comments, right, in the discussion forum. So like let's consider a discussion forum. You'll find many people writing very small comments. There will be average number of people writing medium sized comments, and there will be very less number of people writing very longer comments, right, where they are explaining something, where they are discussing something and all. So whenever we talk about the length of comments in the discussion forum, it usually follows a log normal distribution. Okay. Some more examples with respect to this. So you can hear length of chess games, right? This also follows log normal distribution. There are also some other example like dwell time. Dwell time basically means the time that you spend on online articles, right? Online articles like jokes or news, right? This also probably follows very good log normal distribution. Okay, so here are some of the examples. Most of the data set of this type usually follows a log normal distribution.